Okay, so as promised, here's a video describing the concept behind slip and slide factoring. And the question I asked myself was, is this just a meaningless trick that I'm going to hate forever? Or is there some way to derive it or see where it comes from conceptually to make it a really useful tool? So I'll let you know what I decided at the end. So first, before we get into actual slip and slide steps, let's review a couple things. So the first thing I want to review is how to find the solutions for a quadratic equation by factoring. So remember, if you're given the factors, then you can find out what x is equal to here, because you look for what makes this factor equal 0, which would be 5, and what makes this factor equal 0, which would be negative 7. Or if it gets a little bit messier, you can set each factor equal to 0 and then use Algebra 1 skills to solve for x. So here we would subtract 7 from both sides, so we'd have 2x is equal to negative 7, and then divide both sides by 2. So you'd have one of your solutions as negative 7 halves. And here, if we set 5x minus 1 equal to 0, we would add 1 to both sides, and then we'd have 5x is equal to 1. Then we would divide both sides by 5 and find that the other solution is 1 over 5. I want you to notice in that process what happened here. Your final solution's numerator was always the opposite sign of that constant, and that was the numerator. And then the denominator was always the coefficient of the x. So we could kind of shortcut this if you realize what's going to be happening every time. Is we can always say that the solutions given those factors will always be the opposite of this, so negative 7 divided by this. And here, the opposite of that, because we're going to be adding 5 instead of subtracting 5, and then we divide by the coefficient of x. So we could keep doing that, but that's a nice shortcut for how to find the solutions when you're given kind of messy factors. Now, let's take it a step further and talk about, well, if I give you the solutions, could you work backwards and give me a quadratic function? So, and you can. So if we have this question that says, find the equation of a quadratic function with the following zeros. If you know that the zeros are 5, negative 3, then you can say that the original factors were x minus 5, right? Because 5 minus 5 is 0, and x plus 3, because negative 3 plus 3 is 0. So what we can say now is we can say that if these are the zeros, then we've found a potential or one of the possible quadratic functions that has that as the zeros. And then keep in mind here, we're kind of toggling back and forth between quadratic expressions, quadratic equations, and quadratic functions. They're all really closely related, but maybe in the end, it's just asking you to give the quadratic expression that has a related function with these zeros. So there's some different contexts where we can talk about these ideas, and just keep in mind that sometimes it's an expression that's factorable, sometimes it's a function that's graphable, and then you can find the zeros or the x-intercepts, and then sometimes it's an equation where you can factor it and just mathematically find the zeros or solutions. So here, if our solutions are a little bit messier, we can still use what we talked about above right here to figure out what the factors are. So remember, the numerator is always opposite sign as the second term in one of the factors, and then the denominator is the coefficient of the x. And then for our second factor, our numerator, the opposite sign of our numerator gives the second term in our factor, and then the denominator gives the coefficient of our x. So what we have right here is a related quadratic. If we want to say quadratic equation, we can set it equal to 0. If we wanted to say quadratic function, we could set it equal to y. Now, keep in mind that this is only one of the potential quadratic functions that would have those two numbers as the solution. If you have, you could factor out a 10 here and it wouldn't change the solution, or you could have a 5 here, or you could have a 2 here. But notice your solutions would still be the same thing. Okay, and then the last thing I want to review before we actually get into slip and slide is let's look at how zeros of functions are affected by horizontal compressions. It's possible to have also horizontal stretch, but for the sake of this video, we're going to just talk about compressions. So here, if we have a function g of x and it's equal to f of 2x, and the function f of x has these zeros, 3 and 8, well, what are the zeros of g of x? Well, remember from transformations, if you have a 2x inside the function, we need to multiply our x values by 1 over 2. So the zeros of g of x would be 3 times 1 over 2 and 8 times 1 over 2. So what are the zeros of g of x? Well, it would be 3 halves and 8 halves, which reduces down to 4. So what we can do is we can also apply the transformation rules to zeros of functions because we know that the x values are multiplied by the reciprocal of the coefficient of the x. So here, if we had that g of x is equal to f of 5x, and then we know that f of x has these zeros, well, we can say the zeros of g of x because they're going to be 1/5 of the zeros of f of x. So that means the zeros of g of x are going to be negative 9/5 and 10/5, which is 2. Okay, so keep all of that in mind, and we're actually going to get into slip and slide now. So here we go. So the first thing I want to do is talk about a function and its transformation. But I want you to first look at this. So we've got g of x, and this is a quadratic function for which if we wanted to solve by factoring, we could apply slip and slide. And if we did apply slip and slide, it would turn into this f of x function. Why? Because we multiply 3 and negative 5, and then we get negative 15 for the c value, and then the a value becomes a 1. So just first off, notice how I got f of x from that original function. Now, if I were to use transformations to horizontally compress f of x, I could say that f of x is equal, or excuse me, that h of x is equal to f of 3x. Now, if we actually applied that f of 3x in terms of x to find the equation or the new function rule in terms of x, what we would do is we would plug in a 3x in place of x squared. So we started off with x squared minus 2x minus 15, and this is where we're replacing the x values with that transformation. So instead of x squared, we end up with 3x squared minus 2 instead of x, we end up with 2 times 3x, and then the minus 15 is just already there. So recognize now, if we simplify that, we would get this function right here. It initially doesn't look like our very first g of x function, but watch. If we factor out a 3, now it does. So look at this. We've got 3 times 3x squared minus 2x minus 5, and that's the exact same function as this one. And then notice this. Even though the function originally would be skinnier than this one, that 3, that factor of 3 right here, doesn't affect the final solution or the final zeros. So let's talk about that. If you talk about these two functions in terms of how their x values relate to each other, we would say that the x values of h of x are 1/3 the x values of f of x. And look, that's true. The zeros or the solutions of that h of x are whatever the solutions are of f of x divided by 3. And then notice that this original function has the exact same solutions. So here's the big picture now. If we know the zeros of this, then we can divide it by the coefficient or the a value to find the zeros of this. And if we know the zeros of this, we can find the factors. So let's do some examples of that. Notice here, I'm going to start off with this polynomial. Now I'm going to not only multiply 5 and 12 to get 60, but I'm going to look at this as the related quadratic function. Notice I put it equal to y right here. Now it's factorable, pretty easily factorable, and I know those are my solutions. What do I know now is that the solutions for this one, if we did the related function, would be 1/5 of these. So what do we get? We get negative 15 divided by 5, so we get negative 3, and negative 4 divided by 5, so we just get negative 4/5. If we know those are the zeros, then we know those are the factors. Let's try another one. If we start off with that trinomial, we apply at least the beginning of slip and slide and multiply 5 times 9, then we get this trinomial. I'm going to go ahead and set this equal to y so we can solve it. So now we can factor and find that the solutions to that second equation are 15 and negative 3. We know now that this one, if we looked at the related function, the solutions are going to be 1/5 again of these solutions. So we say 15 divided by 5 to get 3, and negative 3 divided by 5, and that one doesn't get simplified, but now because we know the solutions, we also know the factors. Okay, this one, here's our original trinomial. We're going to multiply 2 and 5 to get this related function, or I took it a step further and replaced the y with 0 to get the equation. Here's our factors. So these are our solutions. The solutions of this one will be half of the other. So instead of -10, it's going to be -10/2, which is -5. Instead of -1, it's going to be -1/2. And now that we know the solutions, we can back up and find the factors. Okay, so next one, we've got this trinomial. We'll apply the beginning of slip and slide, multiply 4 and -25 to get this trinomial. We factor it easily. If this were a quadratic equation, we would say that the solutions are 20 and -5. I'm going to go ahead and make this is equal to y. So we know that the solutions for this, if we changed that into a function, would be a fourth of these. So 20 divided by 4 is 5, and -5 divided by 4 doesn't simplify. But now we can work backwards and find that the factors are n minus 5 and 4x plus 5. And finally, one more. If we multiply 4 and 4, we get 16. So we've got this related trinomial. Go ahead and set it equal to y. And if we factor it, we get those factors. And from the factors, we find the solutions. We know that this one, if we did the related quadratic function, the solutions would be 1/4 of these solutions. So 16 divided by 4 gives us 4. And 1 divided by 4 is not simplifiable, but we can use those solutions to back up and find the factors. So, conclusion here. Slip and slide does allow you to create a function that is essentially compressed, and every once in a while it could be stretched by a factor of 1/a. So then the zeros will be different by a factor also of 1/a. So if you can find the zeros of the easier function where you multiply the a and the c value, then you can multiply those zeros or those solutions by 1/the a value and then back up to find your factors. So final verdict is, do I like slip and slide? I absolutely think it's such a cool concept. I don't love the way it's taught. So this is probably how I would teach it instead of the way that it's traditionally taught. This is slip and slide Miss Jones style. So first step is we're going to do the normal first step of slip and slide. We're going to multiply a and c and then factor the resulting trinomial that has an a value of 1. Then next, this is where it's going to get different. We're going to find the zeros of the related function that we got from this resulting trinomial. We're going to multiply those zeros by 1/the a value that we had here. And then we're going to use the zeros to work backwards to find the factors of the harder trinomial. So there you go. Slip and slide, a conceptual way. I hope you like it. I think it's kind of amazing. And I'll see you next time.